Hello and good afternoon, CSI257 Section 847 students for the first 8-week term of the spring 2015 semester at Anne Arundel Community College. Today's PacketTracer tutorial video is going to be on PacketTracer Activity 8.1.2.5, where we're going to take a look at performing manual route summarization for IPv4 and IPv6. If we take a look over here to the right, we see the addressing table that we should be very accustomed to at this point. And our objectives are simply we're going to be configuring manual summarization. So we're going to have to calculate and configure what those summary addresses are going to be. And it has told us up here that Eigrp is already configured. We just need to go ahead and take care of the summary route. So let's jump in here on part 1. Configure Eigrp manual summary routes for IPv4. So we're going to go ahead and display the routing table on each IPv4 enabled router and verify that all IPv4 routes are visible. And we can do that over here with branch 2 and branch 1. And we can also ping these loopback interfaces from the HQ IPv4 router to verify. So let's bring up the HQ IPv4 router right now, and let's make that our first order of business. Let me see if I can slide this up just a skosh. There we go. Alright, so let's go ahead and on HQ IPv4 we're going to go from user exec into privilege exec, and I'm simply going to go ahead and issue the ping command about 8 times here. So we'll say 172.31.8.1, and we have connectivity there. And how about 9.1? And let's check 10.1. And let's also check 11.1. So all of the IPs at the branch 4, the loopback interface, I'm sorry, branch 1. Out at branch 1, we have reachability from HQ IPv4. Let's go ahead and extend that and take a look at the loopback interfaces down at branch 2. And finally, we'll take a look at 172.31.15. And we have IP connectivity all the way through. Okay, so let's pull up the IPv4 edge router here, because that looks like it's going to be next in terms of where we're going to be doing some checking right now to see what things look like. So it says by looking at the routing table on IPv4 edge, so I'm going to go ahead and go from user exec into privilege exec and say show IP route. And so there's our routing table right now. As you can see, we're receiving these 8 routes here, 4 of them via serial 000, which is coming from branch 1, and then 4 of them coming from serial or originating out of serial 001. And that's going to be from branch 2. And you can see here these are the IPs that we were just pinging. And it says calculate a summary address for the 4 loopback interfaces on branch 1. And then it says configure branch 1 to advertise an Eigrp summary route out to IPv4 edge. And then the last step in step 2 is going to be verify that IPv4 edge only has one summary route that represents all 4 of the networks that you see there on the branch 1 router. So the first thing that we want to do is we want to go ahead and calculate what that summary is going to be. And I'm going to do it down here in the white space area right down here. So again, remembering how do we perform summarization? Well, we're looking for that interesting octet, right? And it's going to be the 3rd octet right here. And why is it interesting? Well, the first octet, 172, is the same across all 4 of these loopback interfaces. And then the same goes for the second octet. That's also the same. So we've got 16 bits already that are the same. However, when we get to the 3rd octet here, you can see where the 3rd octet is different. It's .8, .9, .10, and .11. And so that's where we begin our conversation as to how do we summarize these 4 addresses. So let's convert the decimal representation here into binary. And so 8 in binary would be 1, 2, 3, 4. So it's going to be 0, 0, 0, 0. And then it's going to be 1, 0, 0, 0. And so again, remembering that the value of the first location is 1, and then 2, and then 4, and then 8. And this is going to allow us to add up these binary, these bit positions here, to come up with our decimal number. So in this case, it's 8. So how about 9? Well, 9 should be pretty easy. So we'll say 0, 0, 0, 1, 0, 0, 1, and that would equal 9. So this is our binary, and this is our decimal. Okay, so now we're going to come to 10. So 0, 0, 0, 0, and 8, 0, 1, 0. So the 8 positions on and the 2 positions on, I should say. I said 1 because I was writing the 1 there. So, but that position has a value of 2, and that position has a value of 8. So that gives us 10. And then we have 11, 0, 0, 0, 0, and that's 8. And the 4 position won't be on because that would take us to 12, so it'll be 0. And then we've got 2 to get to 10 and 1 to get to 11. So now that we've taken the third octet, we've converted the values from the 4 loopback interfaces from decimal into binary. Now we need to take a look at our values here and figure out where are these bits no longer the same. So we take a look here. This column, it's all zeros. We're good. All zeros, all zeros, all zeros. Now we've got all ones here, and that's good. Then we've got all zeros again. Aha. So it's right here after the 6th bit position where we no longer have all 4 bits matching up. And so remember, the first 16 bits already match because of the 172.31. So now we have 17, 18, 19, 20, 21, and 22. So right now we know our CIDR notation is going to be a /22, right? We also know that if that was written out as a subnet mask, we would have 255.255 dot, and again, here's this third octet, and it's going to be a /22. If it was a /24, it would be 255. /23 would be 252, and so this is going to be 248.0. And so this is going to be the summary CIDR notation, and here is our summary net mask. Now the only question left to answer is, all right, what is that single address that we're going to use to represent these 4 networks, the .8, the .9, the .10, and the .11? Well, it would be 172.31, and we know that because those were already the same. However, the third octet, it's going to take this value, right? Remember that that value is on. So it would be 172.31.8.0/22. And so this, for branch 1, will be our summary address. So we have 172.31.8.0/22, and that is our subnet mask. So go ahead and make a note of that. I'm actually going to go ahead and clear the screen here in just 2 seconds. So making a quick note, and let's go ahead and say Control-N to clear the screen, and we'll come back now. So now that we've calculated that summary address for branch 1, let's jump onto that branch 1 router and let's go ahead and perform that configuration. So we'll go ahead and stretch that over here. All right, so we're on the branch 1 router. I'm going to go from user exec to privilege exec and configure it to advertise. Let's do a show IP interface brief. There's only one interface, physical interface that's up. It's serial 000. So I'm going to say config T to go to global config, and I'm going to say interface serial 000. And now what we're going to do is it's under the interface here where we're going to configure the IP summary address, Eigrp, and I probably should have taken a look here real quick to make sure that it is Eigrp is the autonomous system number is 1. Let's take a look. Do show run, And let's see, yep, it is Eigrp1. So I am going to say IP summary address Eigrp1, and then here, if I do the question mark, this is where we put in that summary IP. So we came up with 172.31.8.0, and then it's going to ask for the network mask, or the net mask, 255.248.0. And if I do a question mark, you can see we can place an administrative distance on the summary, but that's not a requirement here, so I'm going to go ahead and hit enter. And when I do that, we should see that the summary has been added now. So let's go ahead. It says verify that IPv4 Edge now has only one route instead of those multiple routes. So let's take a look here. And do we see a single summary route? And did I typo that? I may have miscalculated. Oh, 254. It should be 252 is where I think I made the mistake. So I've got a /21 here, and that is not what I wanted. We wanted to do a /22. So it looks like I may have misconfigured the summary. So we're going to pop this out here. And I did. So 255 would have been, if it was all 255, 255, 255, that would have been a /24. /23 would have been 254. And a /22 is a 252. So let's fix that up right here. So let's get the correct summary address added in. There we go. All right, so now if we come back over to IPv4 Edge, we should see that we have a /22, a single /22, that represents all four of those routes. And so if we were to come back over here to HQ IPv4 and we were to ping the 8.1 and the 9.1, whoops, not the 10.1, I guess we'll get to the 10.1. So the 9.1, we did the 10.1, and how about the 11.1? And we still have connectivity, so that looks good. All right, so for step 3, calculate and configure and verify a summary route on branch 2. So the steps are going to be the same. Whoops. Steps are going to be the same here for step 3, except we're taking a look at branch 2's addresses. And so, again, same exact process that we used before. The first 8 bits here in the first octet are the same. The first 8 bits in the second octet are the same. So we've got 16 bits that match already. Where's our interesting octet? Well, it happens to be right here again. It's our third octet. So now we need to take these decimal values and convert them to binary. And so 12 is going to be 0, 0, 0, 0. We know that the 5th position there is a value of 8. The position right next to it has a value of 4. That gives us 12, 0, 0. So that equals 12. So 13, 4, and then we've got 1, 1, 0, 1, and that's 13. And then 14 is going to be 1110, and that's 14. And then 15, as you have probably already guessed, will be all ones, right? So then we follow the same process. We take a look here and see, okay, these match, these match, these match, these match. The ones here match in the 5th position. The 6th position matches. But again, it's after the 6th position where the 7th and 8th position do not match. So we have 6 additional positions that match. So 16 plus 6 gives us our /22. And then let's make sure we get the math right on this time. 255.255.252.0 is going to be our net mask. So then the question becomes, what is the value that we use for the third octet in the IP? So it's going to be 172.31. We take a look here, we have 2 bit values that are on where we match. It's the 8 and the 4, so that's going to be 12.0/22. So let's go ahead and do the same thing we did last time. Let's clear the screen here. And we're going to pull up the branch 2 router. And let me make this a little larger. All right, so on the branch 2 router, we're going to go from user exec into privilege exec. And then in the global config, let's do a do show IP interface brief. And I'm looking for the physically configured serial 001. So we're going to say interface serial 001. And we're going to say IP summary address, Eigrp, we know it's 1 because it's in the same autonomous system. And now let's configure that summary address. So it's going to be 172.31.12.0, and this time we've got our math correct here, 252.0. So we're going to go ahead and hit enter. And now we're going to step out here to IPv4 Edge, where we should only see 2 Eigrp learned routes coming from branch 1 and branch 2, and they are both /22 summary routes. And so this single entry here represents the 4 routes on router or on branch 1, and this single entry here represents the 4 loopback interfaces, the 4 routes that we were learning from the branch 2. All right, so now it says calculate and configure and verify a summary route on IPv4 Edge. So it says although HQ IPv4 has 2 routes that represent the 8 loopbacks. So let's take a look here. Let's do a do show IP route or show IP route here. And do we have those 2 summaries? We certainly do. So here are those 2 summaries. So we're learning both of those summaries, but we're learning them from IPv4 Edge, because you'll notice what you don't see here, right? Remember we came back and pinged here? We ran some ping commands. Well, you don't see any kind of flapping with the adjacency or with the routes that we did see each time, and there it is right there, each time we did our summary, right? And you don't see that over here. So HQ IPv4, he's simply learning those 2 summaries. He's learning them from IPv4 Edge. So is there an opportunity here for us to take the 2 summaries and consolidate those down even further to a single summary between IPv4 Edge and HQ IPv4? And there is. So let's go ahead and take advantage of that right now. So it says calculate a summary address for the 2 routes in the IPv4 Edge's routing table. So basically we're going to do the same thing that we just did, except we're going to do it on IPv4 Edge, and we're going to do it for the 2 summaries that we've learned so far. So we're going to have to summarize. If we wanted to do 1 summary, how could we summarize all 8 of those routes to come up with a single summary? So let's go ahead and make that happen. So we already know the interesting octet for all of these is that 3rd octet, right? And we've already been through the process, so this should be pretty straightforward. So we're going to have 8, 2, 3, 4, and then we have 8. And then we have 9, which would be 1001. We have 10, which is going to be 1010. And then 11 is 1011. So 12 we saw is 1100. 13 is 1101. 14 is 1110. And then finally 1111. And again, these 4 bits here are the same all the way down. So we've got 16 that match with the 8 addresses we were looking at, starting from 8 and going all the way to 15. So they all match right here. However, it's right there. After that 5th bit, they no longer match. So we've got 1, 2, 3, 4, 5 additional bits that match. So we know we're going to have a /21, which is going to be 255, 255, dot, and it was 250.52 for a /22. It's going to be 248 for our /21. So now we're going to be using 248, which we've seen before. So the question here becomes, what is the 3rd octet in the IP? So we know it's going to be 172.31. However, what is that 3rd octet? Well, we come over here and take a look, which is the only value position that is on where all the bits match, and it's that 5th position with a value of 8. Whoops, pull that one out, 8.0/21. So this is the single summary that represents these 8 routes. And it's important to note that this summary represents these 8 routes and only those 8 routes. And the reason we know that is there are how many bits that don't match here? There are 3 bits that don't match. So if I take 2 to the number of bits and raise it to the number of bits that don't match, that tells me how many networks I'm going to match. And so I'm going to match 8 networks and 8 networks only, and it just so happens it's these inclusive because we have every possible combination of the last 3 bits. So again, if let's say maybe if it didn't include 14 and it didn't include 15, right? The summary is still the same. It's still going to be this exact same summary. However, keep in mind that that summary would be representing 14 and 15 as well, even though they aren't configured, right? So if you were to bring those online later, you would want to be aware of the fact that this summary is representing 8 addresses. All right, so we've got our summary. We know our subnet mask. Let's go ahead and configure things on IPv4 Edge. So we'll clear our screen here. And let's step over to IPv4 Edge. And which interface is facing HQ IPv4? That's the interface on which we're going to go ahead and configure our summary. So, and that's probably going to be, yep, serial 010. So I'm going to go to global config mode, conf t, and we're going to say interface serial 010, and I'm going to say IP summary address Eigrp 1, and what's our summary address? Well, it's 172.31.8.0, and then the most important thing here is our subnet mask, so we have correct this time, and it's going to be 248.0. And so I'm going to go ahead and hit enter here. And as you can see, there was a small change, right? Adjacency change, neighbor change. And so now if I go to HQ IPv4 and I type in show IP route, what are we going to expect to see here? Well, before we had 2 summaries, right? And you can see the 2 summary routes we were picking up here, the 2/22s. So what we should see now is a single /21 that is representing both of those routes. And so we're summarizing from the edge to the headquarters. We're summarizing from the branches to the edge. Let's see, do we still have full connectivity all the way through? So let's say ping 172.31.8.1. We've got connectivity. How about 9? And then we'll check 10. And then let's check 11 and 12. And then 13. Let's make sure we didn't lose anybody in here. And then 14 and 15. All right, so we've got connectivity through to all of our routes, and so we've successfully been able to configure our manual summarization for IPv4, right? So that takes us through the IPv4 configuration piece. Now, you'll notice it's interesting. I just noticed here that it's given us all 50 points. However, we now have the IPv6 configuration portion that we're going to need to execute on here. So let's go ahead and jump in, and I'm actually going to slide this up just so we can see the IPv6 information. So it looks like we're going to be doing the same thing here. So again, we're going to display the routing table, and we're going to calculate and configure a summary route on branch 3. So let's pull branch 3 up here. And this guy is going to be all IPv6, which is going to require one additional step in our summarization process. So I'm on branch 3 right now. And let's go ahead and calculate what the IPv6 summary is going to look like. And that's why I moved it up a little bit to give us some more room, because we're definitely going to need it. So remember, IPv6 addresses are substantially different than IPv4 addresses. First, they're 128 bits, right? And they're also represented in hexadecimal, as opposed to the decimal numbers that we see here. So this is going to require one additional step. So the first step that we're going to take is, again, we're going to find the interesting hextet. So for IPv4, we needed the interesting octet. Over here, we need the interesting hextet. So we take a look, and it's the same there, but here we go right here. So in the 4th hextet, right after the first 48 bits, we find the interesting hextet. and we have the value 8. Now here's the key, right? Remember that because of the rule of zeros, right, the leading zeros that you would normally see that precede these hex characters, they've been dropped for brevity. So 8 isn't just 8. It's actually, and let me drop this off here, it's actually 0, 0, 0, 8, and 0, 0, 0, 9, and 0, 0, 0, A, and then 0, 0, 0, B, right? Because we have our A and our B. And the key thing to remember is that this is hexadecimal, okay? And in this hextet, each hexadecimal character is the equivalent, we'll swing this over here, to 4 bits, right? So 0 is actually 1, 2, 3, 4, and then the same thing, 2, 3, 4. So when we go from hex to decimal, we end up with 4 characters. Now here's the key. So what is 8? Well, if we're only dealing with 4 bits, what are the values of these bits? Just like when we did the equation earlier. So the least significant bit is 1, and then 2, and then 4, and then 8. And remember, when we did our work here going from decimal to binary, we worked it out with 8 bits in the octet, and then we kept going up, 16, 32, 64, and 128. However, hexadecimal, we're only concerned about the least significant 4 bits. So if we have 8, we know that that would be, sorry about that, that would be 1, 0, 0, 0, right? And so what's 9? 9 is going to be 1, 0, 0, 1. And then B is going to be 1, 0, 1, 0. Because, I'm sorry, A. I think I said B. So A is 1, 0, 1, 0 because A would have a decimal value of 10. So it would be 8 plus 2. So what about B? Well, B would have a decimal value of 11, which would be equal to 8, and then a 0, and then the 2 position, and then the 1 position. So we've got these characters here. So we're actually subnetting in IPv6. We're performing our subnetting. In this case, it's going to be on the boundary right there. So now we need to line these guys up. So let me make this a little clearer here. So we're going to say 8 is 1, 0, 0, 0. 9 is 1, 0, 0, 1. 10, 1, 0, 1, 0. And 11, 1, 0, 1, 1. So now we look at these bit positions and we do the exact same thing because now we're dealing with binary. So we do what we did before. This position matches and the next position matches. However, right here within this hexadecimal setup here, the binary digits that we have, they don't match here. So how many additional bits match? Well, we've got 4. Remember, there's 4 zeros that represent that single hexadecimal 0. So 4 binary zeros represent that single hexadecimal character. So we've got 4, 8, 12, 13, and 14. So we've got 14 additional bits that match in addition to, remember, each hextet is 16 characters, so 16 plus 16 plus 16 is 48. So that leaves us with 62. So we know right now that our prefix length, right, not the subnet mask, the prefix length will be a /62. Now comes the additional step where we need to now roll this back to get the hexadecimal character. And we do that very similar to how we did it before. We know right now that the boundary for where characters match was right here, or where the binary digits match was right here. So we take a look at these binary digits over here and say, okay, are any of these values on? Well, yes, that is. This value position is on, and that is a value of 8. But it's not 8 in binary, it's 8 in hex, right? It's hexadecimal. So, and you'll see when we go to do the C, D, E, F, where you've got to convert it, and that's typically where new learners make the mistake, is that they'll get here and say, oh, it's 8. Or and maybe let's say that this position was on here, they'd say, oh, it's 12. So when they take the 12, they don't convert the 12 to a C, they just drop the 12 in there and they say, oh, and let me clear the screen here, let's get some space. The common mistake is, so it's going to be 2001 colon DB8 colon 1, that's a terrible 1, let's fix that up there, 1 colon, and so what is our hexadecimal value? It's 8. Remember I was saying, when we get down here, a common mistake people make is they will get down and they'll figure out, oh, well, it's 1100, and so it's 12, and they write 12 here instead of converting this from binary to decimal, and the additional step is from decimal to hex, because we need to represent it as hex. So it's 8 colon 1 slash 62. And so that's going to be our summary. Oops, sorry, colon slash 62. So this is going to be our IPv6 summary address, right? And it's going to have the 8 here, but that is not a decimal 8. That is a hex character right there, okay? All right, so let's go ahead and clear our screen here, and let's jump back in. So we're going to do the same thing we did last time. Let's hop onto branch 3, and we're going to go from user exec to privilege exec into global config, do show IP interface brief, so we can see which interface, which physical interface we're actually, oh, sorry about that. And did anybody pick up on the mistake there? Do show IPv6 interface brief to see the interface that we have up right now, and it is serial 000. So let's go ahead and go into interface serial 000, and what would we say? We would say IPv6 summary address Eigrp 1, and what is that prefix going to be? Well, it would be 2001 colon DB8 colon 1 colon 8 colon slash 62. And so we drop that in, and if we were to take a look now, and as you can see we had an adjacency change there, if we come over and take a look now on router IPv6 edge, and we'll bring our CLI up here, if I go into privilege exec and say show IP route, and how about show IPv6 route, which is why we don't see anything, we should see our /62 summary, and it is right here, and it's being learned on our serial 000 interface. And as you can see, who is our successor? It is FE80 colon 3, which is going to be branch 3. Let's make sure we still have connectivity. Let's ping these routes. So 2001 colon DB8 colon 1 colon 8 colon 1. We have connectivity there. How about to 9? And it's not 10, it's going to be A. And then how about B? All right, so we've got connectivity all the way through from the IPv6 edge. Let's go ahead now and calculate the summary. And this should be pretty quick because we should be pretty comfortable at this point with doing the calculation of the summary. So these 16 bits match, these 16 bits match, and these 16 bits match. So we've got 48 bits that match. Where is the interesting hextet? It is right here. And now this, again, is where you'll see a lot of mistakes get made. So C, the hexadecimal character C, what does that equal in decimal? Well, it equals 12. So in binary, we would write that for the 4 bits that are going to represent that hex character, 1100 is 12. So then we have D, and D in decimal is 13, and binary it's 1101. And what about E? Well, E is 14, and that is 1110. And then finally F is 15, which is 1111. So now when we take a look at this, we see the same pattern we saw earlier, where the first 2 bits match, and that's where the boundary is, right? They stop matching there. So we know that we've got 2 additional bits that are going to match. However, remember that how are these actually, those hextets aren't actually just a single hexadecimal character. It's actually 000 Charlie, 000 Delta, 000 Echo, and 000 Foxtrot. So each of these hex characters is the equivalent of 4 binary digits. 2, 3, 4. So how many of these match? Just by looking at this here, it's the same as before. It's 12 additional characters that match, all of our zeros, right? The 4 binary digits that represent each of the hexadecimal zeros. And then finally, these last 2 bits here. So we've got 14 bits again. So 48 plus 14 is going to be 62. So we know we're going to have a prefix length of /62. Now, again, this is where we've got to reconvert this back into a hexadecimal character, and here's the additional step where the mistake is typically made. So I look at these and I say, oh, okay, well, in binary, the 8 position plus the 4 position is 12. So then my summary is going to be 2001, and this is the mistake that gets made, db8 :1 :12 : /62. That is wrong, because remember, we go from binary to decimal to hex, and 12 in hex is Charlie. So what we're looking for here is 2001 : db8 :1 Charlie /62. And that is our IPv6 global unicast address with the prefix length of /62. That is going to be our summary route. So let me clear the screen here. And let's come back over to branch 4, where we're going to go ahead and perform that configuration right now. So actually I can raise this up a little bit. So let's pull the CLI up on branch 4. We're going to go from user exec to privilege exec into global config. And I'm going to say do show IPv6 interface brief. And let's see, what interface are we using here? Just like on the other side, we're using serial 001. So I'm going to say interface serial 001. And I'm going to say IPv6 summary address Eigrp 1. And now we're going to put that summary address in here. So it's going to be 2001 : db8 :1 Charlie /62. And we should see the adjacency reset there. And let's now go back out to IPv6 Edge. We're going to raise it up just a skosh there so we can see a little bit more real estate. And I'm now going to say show IPv6 route. So we should now have 2 /62s. And there they are right there. Both of the summaries that represent all 4 of the routes behind branch 4 and the other 4 routes behind branch 3. So let's test our pings here. Let's say ping 2001 : db8 :1 Charlie :1. And then we'll change that to Delta, and then to Echo, and then over to Foxtrot. All right, so we've got our connectivity there. Same thing now is we're going to look at, we're on IPv6 Edge, and we're going to do a summary that we can place on this interface right here, which should be the serial 010 interface brief, if it's the same. Oh, sorry about that. So we're going to say do. All right, so we are using serial 010. There it is right there. And so that's our connection out to the HQ IPv6 router. So how would we do the calculation? Well, it's the same process as before. We know the interesting hextet. We're familiar with all of these values. So really, the leading zeros, right, we know that's going to give us 12 additional bits. Because remember, each of the zeros, the 3 zeros that are missing here, are represented in binary as 4 zeros. So the hexadecimal 0, right? So if it's hex 0, it's going to equal 4 zeros in binary. So we know we've got 48 bits plus the 12 bits from the zeros. That gives us 60. Well, how many additional bits are we going to have here? So let's just do the 4 binary characters. So we're going to do this. I'll make a little chart here. So we're going to say the hex number, and then I'm going to say what is that in binary right next to it, and then we can say, we can even take a look at the decimal value, right? So the hexadecimal character 8 in binary is 1000. In decimal, it's 8. So 9, 1001, 9. And what about A? Well, A is it's 10 in decimal, which is 1010. B is 11, which would be 1011. C is 12, so it's going to be 1100. D is 13, which is going to be 1101. E is 14, so it's going to be 1110. And finally, F is 1111, the easiest one to remember, and that's 15. So we do the same thing we did before. We take a look at the binary, right? And we say to ourselves, where do these not match? Well, it's pretty obvious here that we get one additional bit that's going to match, and that's it. So we end up with a /61 prefix length. Now we need to look at this and say, okay, what is this position? What is that bit position in binary equivalent to? Well, it's equivalent to decimal 8. Well, it just so turns out that the decimal value and the hex value for this binary bit position are the same. It's just 8. Now, had it been 11, that would have been 12, so it would have been Charlie like it was before, but it's just the number 8. So what is our summary global address? It's going to be 2001:DB8:1:8:/61, and that is our summary address. So let's get that added in here. Let's clear our screen. All right, so I'm going to go ahead and jump onto the IPv6 Edge router, and we know that we're looking at the serial. I apologize, dropped my pen twice there. The interface we're working with is the serial 010 interface, and so we're going to say, we're going to go to global config mode, and I'm going to say interface serial 010, and we're going to do our IPv6 summary address. And let me go ahead and confirm before we do that so we can see the difference. Let's take a look at what that's going to look like. Make this a little larger here. Okay, so if I were to go to global config mode and say show IPv6 route, what do we see right now? Well, we see the 2/62s because that's what's being advertised. However, once we make our change on IPv6 Edge, just like with the IPv4 Edge, we should only see a single IPv6 summary address. So we say IPv6 summary address Eigrp 1, and then what is our summary address? 2001:DB8:1:8:/61, and then we hit enter. As you can see, we've got some activity there. And now let's step back over here to HQ IPv6 Edge, where we should now have a single entry that is representing all 8 of those IPv6 addresses. And so our final step here, let's test connectivity. It's always a good idea to test connectivity to make sure that you didn't lose anything. So we've got 8, let's check 9. We're going to check Alpha, and then Baker, C for Charlie, D for Delta, E for Echo, and then finally, do we still have connectivity out to F for Fox? We do. All right, so that wraps up this PacketTracer video tutorial for PacketTracer Activity 8.1.2.5. where we walked through the process of not only calculating what the summary route was going to be, but we got an opportunity to configure those summaries on our branch routers. We then had a chance to fold those into a single summary and consolidate them on our edge routers. And then we looked at our HQ router, and that's where we ended up with a single summary address representing 8 different subnets. All right, well, hopefully this has cleared up any confusion you may have had and provided some clarity for you on IPv6 and IPv4 manual route summarization in Eigrp. Thanks for watching, and I will see you guys on Saturday.